Scientists around the world have now issued a serious warning about the return of a major solar storm. They said that this time it will be more powerful and could become one of the most violent solar events of this century. This week, a particularly notorious sunspot is making its return to face Earth, bringing with it the potential for significant geomagnetic activity. This sunspot, named AR 3664, has already proven to be a formidable force in the realm of solar phenomena. The size of this sunspot is so large that it is changing the natural vibrations of the Sun and forcing the entire star to vibrate in an unusual way. Also, this sunspot is larger than the sunspot that caused the Carrington event in 1859. Earlier this month, it was responsible for generating the strongest magnetic storm in 2 decades. As it turns back toward our planet, experts are watching closely for potential impacts, which could range from beautiful auroras to more disruptive events like blackouts. Sunspots are dark areas on the Sun's surface that are cooler than the surrounding regions. They are caused by magnetic activity within the Sun and can lead to solar flares and coronal mass ejections. These phenomena occur when the magnetic energy that has built up in the Sun's atmosphere is suddenly released. The result can be massive bursts of radiation and particles, which can travel across the solar system and interact with Earth's magnetic field. But why has the Sun become so active lately? What's causing these huge solar flares? And why are scientists warning us about upcoming solar flares? The Sun is a huge ball of electrically charged hot gas that moves, generating a powerful magnetic field. This magnetic field goes through a cycle called the solar cycle. Every 11 years or so, the Sun's magnetic field completely flips, meaning the Sun's north and south poles switch places. This solar cycle affects activity on the surface of the Sun, such as sunspots, which are caused by the Sun's magnetic fields. One way to track the solar cycle is by counting the number of sunspots. The beginning of a solar cycle is a solar minimum, or when the Sun has the least sunspots. Over time, solar activity and the number of sunspots increases. The middle of the solar cycle is the solar maximum, or when the Sun has the most sunspots. As the cycle ends, it fades back to the solar minimum, and then a new cycle begins. Here you can see the increase in the number of sunspots during the solar maximum phases of 2001 compared to the weak phases of 1996 or 2006. Using this method, Indian astronomers found that the next solar maximum is likely to occur not in 2025 but in early 2024, with flames so strong that they can disrupt the world's internet for weeks. Well, recently, AR 3664 announced its return with a powerful solar flare, as reported by space weather. This flare, classified as an X2.8, is among the most potent types of solar flares the Sun can produce. Solar flares are categorized into classes based on their X-ray brightness, with class X being the strongest. The number following the class letter indicates the flare's strength within that category. An X2.8 flare is particularly intense, making this one of the most significant solar events in recent years. The solar flare from AR 3664 caused a shortwave radio blackout and triggered a coronal mass ejection. During a corona mass ejection, vast amounts of plasma and magnetic particles are ejected from the Sun's surface. These ejections can travel through space and, if directed towards Earth, have the potential to disrupt satellite communications, GPS signals, and power grids. Fortunately, this particular corona mass ejection is not expected to impact Earth. However, the potential for geomagnetic disturbances remains. When AR 3664 was facing Earth earlier in May, it generated a G5 rated solar storm. The geomagnetic storm scale ranges from G1 minor to G5 extreme, and a G5 storm can cause widespread power outages, disrupt satellite operations, and pose risks to astronauts in space. With AR 3664 now returning to an Earth-facing position, there is a possibility of another strong solar storm if it continues to emit particles. The timing of AR 3664's return is particularly notable. It is expected to be fully Earth-facing during the new moon on June 6th. New moons are significant because they bring darker skies, which enhance the visibility of phenomena like the aurora borealis, also known as the northern lights. Auroras are created when charged particles from the sun collide with Earth's atmosphere, causing gases to glow. While a strong geomagnetic storm can cause disruptions, it also enhances auroras, creating stunning displays in the night sky. Just last week, AR 3664 produced an even more powerful solar flare, classified as X12. This is the largest flare it has generated so far, and it caused a massive coronal mass ejection on the side of the sun facing away from Earth. Solar physicist Ryan French from the National Solar Observatory in Boulder, Colorado, highlighted this event on social media, noting the intensity of the flare and its associated CME. The National Oceanic and Atmospheric Administration has indicated that the geomagnetic particles released from the sun this week will not reach Earth immediately due to their remote origin point. This provides a small window of time for scientists and observers to prepare for any potential impacts. Once the sunspot starts to appear more directly, we enter what Ryan French calls a window of opportunity for viewing auroras. For those living in higher latitudes, the prospect of increased auroral activity is exciting. The aurora borealis is one of nature's most beautiful spectacles, with vibrant colors dancing across the sky. While the return of AR 3664 holds the promise of breathtaking auroras, it also brings the risk of geomagnetic storms that can affect technology and infrastructure. Power grids are particularly vulnerable, as intense geomagnetic activity can induce currents in power lines, potentially leading to outages. Satellite communications and navigation systems can also be disrupted, affecting everything from airline operations to GPS-dependent devices. To mitigate these risks, scientists and space weather forecasters closely monitor solar activity. Satellites equipped with instruments to measure solar emissions and magnetic fields provide real-time data, allowing experts to predict and prepare for geomagnetic storms. Organizations like NOAA issue alerts and warnings to help manage and minimize the impacts of these events. In summary, the return of sunspot AR 3664 is a double-edged sword. On one hand, it raises the potential for geomagnetic storms that can disrupt our technological systems. On the other hand, it offers a unique opportunity to witness one of nature's most stunning displays, the aurora borealis. As we look to the skies this week, we do so with both caution and wonder, prepared for the challenges and the beauty that solar activity can bring.